Hello! Today I'll be talking about limits in calculus. A limit is used in calculus and is a way of estimating the value that the y value approaches as x gets closer and closer to an unknown signified as x. Let's say there's a part of your function where the value of the function at x equals 5 doesn't exist. Well, we can use limits to estimate what the value would be at that point. If we plug in 4.9, we get 3.5947. If we plug in 4.99, we get 3.0558. If we plug in 4.999, we get 3.0055. If we plug in 4.9999, we get 3.0005, and so on and so forth. As we get closer and closer to 5, we approach 3. That's what a limit is. It's whatever you approach when you get closer and closer to a number. It's not the exact value of that function at that x, but it's an estimate. Let's do another example. Take a look at this function. What is the limit as x approaches 2? Well, if you plug in 2.1, we get 6.6913. If we plug in 2.01, we get 6.7293. If we plug in 2.001, we get 6.7329. If we plug in 2.0001, we get 6.7332, and so on and so forth. However, if we plug in 1.9, we get 3.1859. If we plug in 1.99, we get 3.2880. If we plug in 1.999, we get 3.2988. If we plug in 1.9999, we get 3.2998, and so on and so forth. It seems as though we can take the limit of x approaches 2 two different ways, and they lead to different results. What gives? Well, you see, the limit of x approaches a value is actually two limits. The limit as x approaches a value from the positive side, and the limit as x approaches a value from the negative side. If these two limits match, the limit as x approaches a certain value exists. However, if they do not match, then the limit as x approaches a certain value does not exist. So, since we got two different answers from our two different limits that we just evaluated, that means that the limit as x approaches 2 does not exist. What are limits used for? Well, they are the basis for the definition of a derivative. The formal definition for the derivative of a function is the limit as h approaches 0 of f of x plus h minus f of x all of that over h.